All right, when you look at this Trig Identities packet, we're just going to go through some examples and some practice on simplifying. This is 5.1. If you notice, the Trig Identities at the top look a little different from the ones that I originally gave you. These ones just have all of the Pythagoreans rearranged in different ways. If you notice, like this top one right here, cosine sine equals 1. They also have it written where sine squared equals and cosine squared equals. I'm going to give you guys the original one that I showed you, and then you're going to have to manipulate, move them around. But that's all that this is. It's not anything extra. So if you come to questions like here in example 1, it says use the trig identities to write each expression as a single trig identity. We're simplifying. So remember, you're going to have questions on your quiz. I don't know how many questions. There's 8, 10, something like that. But some will be simplifying and some will be the second part, which is verifying. If you're going to simplify, you're making smaller. So you're always trying to make the original that you have smaller. If you don't have fractions, don't turn it into a fraction. You're always wanting to simplify. What are the two most basic trig functions that we have? Sine and cosine. Okay, so let's look here. Tangent. Well, how can I rewrite tangent? That would make us be able to simplify a little bit. Tangent's the same as what? Sine over cosine. Agreed. Sine over cosine times, this is cosine over 1, right? Now, we're thinking algebraically. We always think algebraically. If I have two fractions and I'm multiplying, what can I do with the denominator on one and the numerator on the other that are the same? You can cross cancel, right? God bless you. So this just becomes sine theta. And that's all you're doing for simplifying. You're just making smaller. Yeah.
Since sine and cosine are like the simplest, if they were to give it to us like that, should you suggest that we shouldn't change it further?
Say it one more time.
Like, you know how sine and cosine are like the simplest?
Sine and cosine.
Oh, cosine?
Yeah.
Can we just like not change it? Like,
If it's already in sine or cosine, leave it. Mm-hmm. Yeah. All right, let's look at B. Where should my eyes go for the numerator of B? It's a Pythagorean identity. Remember, if something is, a trig function is squared and it's attached to a plus or minus 1, look at your Pythagorean identities. 90% of the time, you're going to use the first one. Sine squared plus cosine squared equals 1, correct? Can I rewrite this so somehow it says 1 minus cosine? What would I have to do? I'd have to move the cosine. If I subtracted cosine squared from both sides, do you guys agree that 1 minus cosine squared is the same as sine squared? Yeah? Okay. So I'm going to replace 1 minus cosine with sine squared theta over cosine squared theta. Now, that is the most basic trig function, sine and cosine. But the directions were to write it as a single trig function. Sine over cosine is the same as what trig function? So this would be tangent squared theta. Say they were both to the 5th power. It would be tangent to the 5th power of theta. Your squared goes on the trig function, not on the angle. Yeah.
What if sine was squared and cosine wasn't?
Then you couldn't. You'd have to do different simplifications. They both have to be the same. Yeah. All right, let's look at D. What do you notice about D? Do you see any plus or minus signs? No, that makes your life so much easier when it's all just multiplication. Because what we should do is break to our simplest trig function. So my numerator, I'm going to keep as sine theta. I'm going to put it over 1. And then how can I rewrite secant? Secant is 1 over cosine. Does everybody agree with me? All right. I'm going to go ahead and break down my denominator. How can I rewrite tangent as what over what? Sine over cosine. All right. Anybody have any questions about what I just did there? Sometimes I simplify vertically. Sometimes I go left to right. So if I confuse you, I'm sorry. I'm going to go left to right now. Can I combine the numerator and write it as sine theta over cosine theta? Yep, we're just multiplying fractions, right? And then it's over sine theta over cosine theta. Now, some of you right now go, oh, I see what the answer is. What is it? It's the same thing divided by itself. It's going to be 1. Right? Some of you see that. Some of you don't. And that's okay. You can go ahead. Remember, we think algebraically. We're going to say we're dividing fractions. So we're going to keep change flip. So sine over cosine times, when I flip, this becomes cosine over sine, right? So now what happens? These cancel. Your answer is 1.
Couldn't you have done like sine over cosine equals
Yep. Here, Allie's saying, couldn't you have changed this to tangent, and then you would have had tangent on the bottom, and you would have had tangent over tangent? Sure. Like I said, you guys are going. The more comfortable you get with this, you're going to start to see things that are like, oh, okay, this makes more sense. All right, again, there's no plus or minus sign here, so life is easy. I'm going to keep cosine. I'm just going to leave it as cosine. I'm going to put it over 1. And then what am I going to change cosecant to? 1 over sine. Perfect. So now when I multiply these two together, I get cosine theta over sine theta, which simplifies to, what is it? Cotangent. Good. Cotangent. You want to be as simplified as possible. 1 over tangent, yes, but then you could simplify that to cotangent. All right, let's move on. We're not going to do all of these because they get to be a little redundant. What about here? As soon as I see a trig function that is squared and it's attached to a plus or minus, what do we think? Pythagorean, okay? The first one, sine squared plus cosine squared equals 1. How could I rewrite this so it says 1 minus cosine squared equals something? We're going to subtract. Good, right? Cosine squared. So 1 minus cosine squared, I can replace my numerator with just sine squared. Over. How can I rewrite tangent squared? Sine over cosine. Good. Now again, sometimes we like to write, I'm just going to rewrite this as sine squared over 1 divided by sine squared over cosine squared. So if we keep change flip, I have sine squared theta over 1 times, what happens here? Keep change flip. So sine squared theta over 1 times what? Cosine squared over sine squared. What happens to my sine squareds? And you're left with cosine squared. Everybody okay? Scoot along. None of these are really difficult. God bless. How about 7? Again, there's no plus or minus, right? So this is easy. I'm going to keep sine. I'm going to keep it as sine theta over 1. What am I going to change cosecant to? 1 over what? 1 over sine. Okay. You guys with me? All right, what am I going to change cotangent to? Cosine over sine. All right, how can we simplify the numerator? The signs will cancel, so I'm left with a 1, right? 1 over cosine theta over sine theta. Still have a fraction divided by a fraction. So if we keep change flip, we have 1 times sine, good, over cosine, which becomes tan. Good. Yeah? All right, look at the last page. Anything interesting? Yeah. All right, how's A a little bit different? We have an addition sign. Now, yesterday we had one of these, and you guys did a great job. We worked through it. If you notice, what do you notice about the denominator? The denominator is the same. It's singular, right? So remember, if we think algebraically, 4 plus x over 7. How could I rewrite that? this is the same as 4 over 7 plus x over 7, right? Can we do the same thing here? Yeah, sure. So let's rewrite this as tangent of theta over tangent theta plus cotangent theta over tangent theta. You guys agree? Okay. Anybody? Could we turn tangent into 1? Sure. Okay, so 1 plus cotangent theta over tangent theta. You want to say 1 plus 1 over tan over 1? Okay, I like the way you're thinking, but can we do that? Can we keep change flip and do that with that plus sign there? Okay, so maybe that wasn't the best thing for us to do from the beginning, and that's okay. I'm doing this on purpose because you guys are going to run into this. It's funny, I'll hear all the time, oh, this isn't so bad. And then as soon as you guys get home, you're like, I can't do it without, yes, I know it's easier when I stand here and go through it with you. I understand that. All right, so let's think a little bit. Let's separate the numerator and the denominator again. What would it be? Okay, tangent theta over tangent theta plus cotangent theta over tangent theta. Okay? Anybody? Oh, for both of them or just one?
Turn the tan into 1, and then the second one we turn it into the simplest
So go here, 1, and then
one.
cosine over sine,
Over.
and then sine over cosine.
Then keep change flip.
But then we still have where we have one part of it where keep change flip and one we're not. Good thinking though. This is, guys, this is important that we think through these problems. I'm telling you, it's very important. All right, we'll come back to that one. I want you guys to think a little bit. I promise you I won't leave you hanging. We have a few more days of working on this. But like I said, always try something. If you just sit and stare at it, it's not going to work itself out. All right, you guys are going to have the identities in front of you. You're going to have to problem solve a little bit. Today, the second part we're going to talk about is verifying. You are going to start off, this is a trigonometric proof. You're going to start off with a true statement. It's going to say the left-hand side equals the right-hand side. It's a true statement. You have to go through and prove it. All right, the first ones we're going to do are fairly simple, and then we'll get to some more involved ones tomorrow and Thursday. But I know these rules seem silly, but it really and truly, you have to work with one side of the equation at a time. You'll see what I mean in a second. Don't start simplifying the left and then go switch to the right. You'll get yourself really confused. Pick one side and work with that one side. You want to look for opportunities to factor an expression, add fractions, square a binomial, create a monomial denominator. What is a monomial denominator? How many terms if it's a monomial? 1. If you have something plus something in the denominator, you want to try to make it into a 1 term so then you can work with it a little easier. You want to use opportunities for fundamental identities, meaning if something is squared and it's attached to a plus or minus 1, look at the Pythagorean. If it's a reciprocal, change it to cosines and sines, stuff like that. All right, try to convert everything to what? Sine and cosine. That will be a very good thing. If all else fails, just go to sines and cosines. See if you can do anything. But the last thing is true. Always try something. Even if you make an attempt that leads to a dead end, it provides you insight. That's what we just did on that last problem. There's 100 different ways that you guys could see and apply these trig identities. Case in point, we just did one, and Allie said, well, wait, couldn't you have done it this way? I said, yeah, sure. So don't just get stuck with, oh, I don't know what to do. Just try something. If all else fails, try to change everything to sine and cosine and see if something presents itself. So here's what these questions are going to look like. All right, it says verify. You are going to start off with a true statement. That is a true statement. Secant squared theta minus 1 divided by secant squared theta equals sine squared theta. So what you're going to do is you're going to use your identities, get your identities next to you, and you are going to prove that the left-hand side equals the right-hand side. So the first thing we're going to do is make a little T-chart. I'm going to try and be as organized as possible. Which side looks more difficult? The left, okay? Whichever side looks more difficult, that's when you want to try and break down. So I'm going to leave the right-hand side alone. I'm leaving sine squared theta. That's our most basic trig function. I'm going to leave it. And I'm going to somehow use my identities to make the left-hand side equal sine squared theta. So as I look in my numerator, where's the first place that I'm going to look on my identity sheet? Why Pythagorean? Because it's squared and attached to a plus or minus 1. Guys, what does secant squared theta minus 1 equal? Tangent squared. Good. So I'm going to replace my numerator with tangent squared theta over secant squared theta. Right away, that helped a bunch because now we don't have any more plus or minuses, right? Now I can just say, like, oh, man, I got this. We're trying to get to sine squared. So how can I simplify my numerator? What can I change tangent to? Perfect. I'm going to change this to sine squared over cosine squared. Great. And then what am I going to change my denominator to? 1 over what? 1 over cosine squared? Okay, agreed. Now, we're trying to get to sine squared. I'm not there yet, but I'm close. I have a fraction divided by a fraction, correct? When you have a fraction divided by a fraction, what do? You keep change flips. So let's go ahead and do that. I'm going to keep sine squared theta over cosine squared theta. I'm going to change my division to multiplication, and then I'm going to flip, and this becomes cosine theta over 1, correct? Now what can I do? My cosines cancel out, right? So what am I left with on the left-hand side? Sine squared theta. Does that equal this side? Yeah? You guys just proved it. That's your verification. Now here's it happens every year. Some of you will get lost. You don't know what you're doing. So you just write a whole bunch of identities down on one side and then do this little squiggly line and write sine squared equals sine squared. Yeah. Right? This is your work, guys. I am going to check your work to make sure that mathematically it supports your proof. Does everybody understand that? That last sine squared equals sine squared with a check mark, that's not really the meat of the problem. The meat of the problem is how you got from the beginning to the end. Make sense? Okay, we're gonna do this. I actually think verifying is easier than simplifying because you already know your end goal. Like you already know, okay, here is the statement. I want it to be the same on either side. So again, here we go. We're going to start. First thing I'm going to do is make my T-chart. And I look at this and I say, okay, which side looks more difficult? The right. All right, let's simplify the right-hand side then. I see two fractions. I don't like fractions. What do you notice about the denominators? This is how you guys should do this. Talk through it. What do you notice about the denominators? They're kind of the same, right? But they're kind of not. Are they squared? No, so I can't just jump to an identity. If I had, now remember, we think algebraically. I have 1 over 6 plus 1 over 7. What would I do to get a common denominator? I'd multiply 6 and 7, right? Can I do the same thing with my trig stuff? Can I multiply those two denominators together? Yeah, absolutely. So my new denominator is going to be 1 minus sine alpha times 1 plus the sine of alpha. If you want to change any of the alpha, theta, beta, if you want to change it to an x, you want to do theta all the time, that's fine. I'm choosing alpha. So if we're going to get a common denominator, right, I look here and I say, okay, the left-hand side has the 1 minus. It needs what? 1 plus? Correct? The right-hand side has the 1 plus. It needs the 1 minus. Everybody agree? Yes or no? Okay. So I'm left with here 1 plus the sine of alpha plus 1 minus the sine of alpha. Everybody agree? Okay, so let's simplify a little more. Let's simplify the numerator. Does anything combine? Does anything cancel out? Signs cancel. And what about the ones? Yeah, they add. 1 plus 1 is 2. Okay. Now I have two binomials that I'm multiplying together. Can I combine those? Can I FOIL 1 minus sign plus 1 plus sign? Okay, so let's do it. 1 times 1 is 1. 1 times sine is plus sine alpha. Negative sine plus 1 is minus sine alpha. And then what's sine times sine? Minus sine squared. Good. Anybody notice anything? These cancel. So I have 2 over 1 minus sine squared. Is that a Pythagorean identity? What's 1 minus sine squared the same as? Perfect. Cosine squared. So look at all of that, guys. We did a lot of simplifying there. I'm trying to get the right-hand side to equal 2 secant squared alpha. Am I almost there? What's another way I could write 2 over cosine squared? 2 times secant squared alpha, right? 1 over cosine is secant, right? So 2 over cosine squared is just 2. Did I prove the left-hand side equals the right-hand side? Yes.
How did you get the answer so quickly from the 2 over cosine?
Because on your Pythagorean, on your identities, secant is the same as 1 over cosine, right? So like secant to the 4th would be the same as 1 over cosine to the 4th. So if I had like 5 over cosine, it'd be the same as 5 times secant. Because in the original, you have 1 over. So when I change that to secant, your coefficient is 1. So whatever the numerator is. Cassie, question, you're just stretching?
No.
Okay. All right, you guys are doing good. We're going to do 2 more. And I'm going to let your brains breathe a little bit. We're going to come back to that one that we started on. All right, now you're like, oh, gosh. First of all, let's write our T-chart. And I like to say, okay, which side looks more difficult? The left, right? So let's simplify it. Now, I notice on the left-hand side, there's no fraction, so that's good. We don't have to worry about that. I do notice that I have trig functions that are attached to a plus or minus 1, and they're also squared, correct? So before you try and FOIL and all that stuff, look on your Pythagorean identities. Does tangent squared plus 1 equal anything? What? Secant squared x, theta, whatever you want to do. All right, now look at your identities again. Cosine squared into 1. Which identity does that resemble? The first one. All right, I needed to say cosine squared minus 1. Ooh, look at you. What happens if I just move the cosine over? What does that become? 1 minus. But I don't need it to say 1 minus. I needed to say cosine minus. So do you guys agree with me? Look, if I move this cosine over, I have sine squared x equals 1 minus cosine squared. You guys agree? Are those two things equivalent? No. But there's got to be some way you can do it. So Allie said, wait a second. What happens if I And again, this is where we think, because we're thinking algebraically. Watch what happens. If I move sine over, so I have minus sine squared x, right? You guys, you see that?
Yeah.
Now, what could I do with what I just did, that first step? What could I do? So my equation said cosine squared minus 1 equals something. I could subtract the 1 here. Very good. So cosine squared x minus 1 equals negative sine squared x. Remember, we think algebraically. All you guys did was just move stuff from one side to the other. That's it. So I'm going to replace this cosine squared with negative sine squared. Good. Now, we've gotten rid of, there's no denominator. We've gotten rid of plus or minus 1s. So now we just break down. What's secant the same as? 1 over cosine squared. Good. Can I leave sine because it's our most basic, just like that? Now, can I do something? What else could I do? If I multiply these two together, I get sine squared x over cosine squared x, right? Yeah? With a negative out in front? Well, what's sine over cosine? Tangent. So this is the same as negative tangent squared x, which is that what we were trying to get to from the beginning? Good. This is not incredibly difficult. Generally, the first step is the hardest. You have to look at it and say, okay, do I have fractions? That means I got to get rid of denominators. Do I have a Pythagorean identity, or can I create one? Once you get all of your plus and minuses out of the way and it's just all multiplication, it's really easy to break down. But it just takes us a second to get there. All right? Let's do one more, and then I'll let you guys breathe for a second. Here we go. Make your T-chart. Which side looks more difficult? Okay, I see why you would say the right, because those are both reciprocal functions, right? But I say the left is more difficult. How come? Is that darn addition sign? I can't just convert everything to sine and cosine and cancel out. So let's work on the left. Let's simplify the left. Where do you guys think we should start? This is the hardest part, is that first step. Turn it into sine and cosine. I know it tells you to do that, but remember, I told you, if you guys are sitting here and you're like, I don't even know where to start, let's walk through. Okay, there's no denominators, so that's good. There's nothing squared attached to a plus or minus 1, okay. So when all else fails, convert everything to sine and cosine and see if that helps. So I'm going to take my tangent and I'm going to write it as sine over cosine. Agreed? Plus, I'm going to take my cotangent and write it as cosine over sine. Now, common mistake. What do you think a common mistake is here that people do? They go, oh, yes, equals 1. Is that true? No. If it was multiplying, yes. But it's not. It's addition. So think about, we're going to think algebraically, guys. We are thinking algebraically. I have two fractions that I'm adding together. What do they need? A common denominator. Okay, so what would my common denominator be between cosine and sine? Cosine, sine. Very good. Cosine, sine. You just multiply them together. Now we go back to third grade. And I got a common denominator, so now I need to see what I need to multiply the numerator by. My first fraction has a cosine. I'm going to multiply it by a sine, correct? My second fraction has a sine. I'm going to multiply it by the cosine. So sine times sine is sine squared, good. Plus cosine times cosine is cosine squared. Well, I'll be darned. What does sine squared plus cosine squared equal? 1. I can take this whole thing and just make it a 1. So 1 over my cosine x times sine x. And we did a really good job here, guys. Now look at where we're trying to go. We're trying to get to secant, cosecant. And look where I'm at. We notice anything? Okay, if I separate, I have 1 over cosine times 1 over sine. Agreed? What's another way I can write 1 over cosine? Secant x times, what's another way I can write 1 over sine? cosecant x, right? Is that what we were trying to get to? Yes. So secant times cosecant. The first step is generally the hardest. All right, you guys, we're going to finish up tomorrow. I'm going to come back to that one. Hopefully, somebody comes in here tomorrow and say, Miss Meadows, not that you math weighed it, but you figured it out. We're going to do the last two. If you notice, the last two are a little more difficult. We're going to finish this up tomorrow. Your WebAssign, I don't want you to stress about it. It's practice. I want you to turn it into a PDF. Ignore the boxes. The whole thing has boxes like this. Ignore those boxes. Take the problem, write it as a T-chart, and just try and simplify the left-hand side, the right-hand side. All right, that's what I want you to do. Tomorrow, we're going to finish up the last two examples. I will answer any questions you have on your WebAssign, and then I have a ton of problems that we're just going to practice on Wednesday and Thursday. Was today a little better? Right? Once you get the hang of it, it's not that bad. It's that first step, though. You always have to try something. All right?